In this section, you'll be learning how to apply the Pythagorean theorem, but the Pythagorean theorem is only used for right angle triangles, and it's very important to remember this. The Pythagorean theorem is used only for right angle triangles, and it can be proven that if you have a square on the hypotenuse of a right triangle, and remember the hypotenuse is the side that faces, or it is opposite to the right angle. Now these are not very good looking squares, but we'll pretend that these are squares. What the Pythagorean theorem says is that the square on the hypotenuse, whose area will be h squared, is equal to the sum of the squares on the other two sides. Okay? And it's very important to remember that. What I would encourage you to do is to memorize the Pythagorean theorem as hypotenuse squared equals leg 1 squared plus leg 2 squared, whereas c squared equals a squared plus b squared is very dear to many of you. It can be dangerous because I could easily draw a triangle like this and call it ABC, in which case the convention is that the side opposite angle is called lowercase a, this is lowercase c and b, and that's another convention. Sides are in lowercase letters and points are always in uppercase. When you have hypotenuse squared equals leg squared plus leg squared, you would get a squared is equal to b squared plus c squared. So the way to memorize the Pythagorean theorem is the hypotenuse squared equals leg 1 squared plus leg 2 squared. What are Pythagorean triples? Pythagorean triples is a set of three positive integers. First of all, they have to be three positive integers, and they have to be integers such that they satisfy the Pythagorean theorem. And if you look at the bolded numbers, the hypotenuse in each case would be the last number. So let's highlight that, because the hypotenuse is always the longest side of a right triangle. So we would say in the first case that 5 squared is equal to 3 squared plus 4 squared, and you can check that out, that works. Now note that in each column, every multiple of 3, 4, 5 is also a Pythagorean triple, and the final row over here, you see it says 3x, 4x, 5x, which means any multiplier at all. It would behoove you to remember or memorize the Pythagorean triple: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Say that about pause the video and say it to yourself 5 times, or to anyone who cares to listen. So now all you have to do is apply the Pythagorean theorem in the following cases. It's pretty simple. Here in this number 1, you see that you have congruency signs, which means that this side will be 11 and so will this side 11. Let me write that a little better. So x will be the hypotenuse, and you can find the hypotenuse using Pythagorean theorem. Always remember to leave your answer in simple radical form, which means do not leave any perfect squares under the radical sign. If you do not know how to answer in simple radical form, just Google it and find out how to write answers in a simple radical form. Pythagorean theorem is very useful in real life, as you will see in number 3, to find distances, find diagonals of rectangles, squares, etc. In number 4, it says find the area of an isosceles triangle. I'm going to just draw this for you on this side. So if this is my isosceles triangle, which means these sides are congruent, they are 20 inches and 20 inches, and the base is 24 inches. Then in order to find the area, you need the altitude. So the altitude, which goes to the base, is going to create two congruent triangles, which means these two triangles will be congruent, which means that the base is split in half by the altitude, and you can use the Pythagorean theorem once again to find the height of the triangle or the altitude of the triangle before you try and find the area of the triangle. Okay, good luck, and this is the end.